Hello guys and welcome back to Engineering Hack, where we try to solve engineering problems in a way that's hopefully easy to understand. Today, just a quick video, just a recap for those who don't know or who forgot about the law of sines. We're going to be using the law of sines for a couple of problems now. It's an easier way to solve specific problems, and therefore just want to do a quick video reminding folks of how the law of sines comes to be. So this is a proof of the law of sines. And the law of sines says the following: if we have a triangle, 1, 2, 3 sides, what the law of sines says is that if this is angle alpha and this is side A, this is angle beta, alpha, beta, and this is side B, and this is angle gamma, this is side C. What we establish is that the sine of alpha divided by the length A equals the sine of beta by the side B equals the sine of gamma. Oops, that's not gamma, this is gamma, side C. Okay, how does that come to be? Well, let's draw, again, any triangle. This is going to be applied to any triangle. Doesn't matter if it's trying to make it a bit less like a street like this. Okay. And what I'm going to do is I'm going to go ahead and copy this just so that I have a copy of it before I put anything else, so that we have another way to do it later if we want to show the other side. Okay. And again, I have an angle here, an angle alpha. This is going to be side A. This is beta and side B. And what I can do here is I can draw a line so that I split this side here right here, and what I'm trying to do is a line that makes exactly 90 degrees on both sides, because we know that this is 180 degrees. So what I will do is a line that specifically cuts this triangle into 2 triangles and exactly mean these 90 and 90. Why? Because now what I can do is I can use just the normal relationship of the sides. Say sine of beta will be this side here over the hypotenuse. So this, right? So that means that what I can show with this triangle now is that the sine of beta equals this side here, which I can call z divided by the hypotenuse, which in this case here is A. And I can do exactly the same thing with this other triangle that I have created here too, right? Because there's a second triangle here. And again, this is a triangle that has that 90 degrees. So that means I can also apply it here. So this is in respect to angle alpha. And there is sine of alpha equals the opposing side, so length of the opposing side, over the hypotenuse, which in this case here is B. So what that means is sine of alpha equals Z divided by B. If I make this solve for Z, I'm going to have sine of alpha times B. You know what I'm going to have over here, if I solve for Z, is that Z equals the sine of beta times A. If Z is the same for both, then I can make this equal, and I'm going to have that the sine of alpha times B equals the sine of beta times A. And if this is true, then I can divide everything by A and by B, and I'm going to have that the sine of alpha over A equals the sine of beta over B. Okay, and this, proves this relationship here, at least this first part of it. And what I can do now is, and that's why I have left the other triangle there, is that I can do exactly the same thing for the other side that I didn't cover, right? So, again, we had alpha over here, we had beta over here, then we have gamma over here. So what I can do is, let's create another triangle, and this time I'm going to do one like, this is not going to work. I need 90 degrees. So this is going to be tough because it's going to be like here. So I'm going to have a very little triangle there. I can also do it there. The other option is to do one over here, which is going to be a bit better because I'm going to have, that's not a good one. Boom, like so. Okay, that's a bit bigger. And what do I have here? I have the angle gamma over here, and I have the angle beta over here. And if you recall, what we had on this side here is C. What we have on this side here is B. Okay, so exactly the same triangle. That's why I copied it, so there's no tricks. Okay, and what I did is I just created two 90-degree angles there. What I'm going to do is I'm going to break it into two triangles. This first one here, I'll try to paint it here. Okay, this first yellow one here, this is going to be sine of gamma. What is that? The opposing one, which is let's change the letters now. This is not Z anymore, this is Y now. Y divided by hypotenuse, which is B. And the blue one, the blue triangle, which I can have my beta times, so sine of beta will be the opposing side, hypotenuse, which is C. Okay, so opposing side Y, hypotenuse, which is C. You know that we have once again exactly the same thing as before. So what this tells us is that the sine of gamma, sine of gamma times B is equal to the sine of beta times C. And therefore, sine of gamma over C equals the sine of beta over B. Okay, so if this is true, and where's the other one? And this is true, then it follows if sine of gamma over C equals sine of beta over B, and sine of alpha over A equals sine of beta over B2, then it also follows that these two have to be the same. Okay, and then we fall into the original proposition, which is this one here. And we just included this part here. Okay, so again, just a recap. A lot of you folks already knew this, so you don't have to watch this video, obviously. But I'm going to refer to it as we solve and use the law of sines, so that, you know, if you forgot about it, you can come here back and check it out. If this was useful, consider giving this video a like. And if you have any questions, leave them down below. We could do a couple more examples on this. And we'll talk soon.